My dear students, today our lecture is about unsigned and signed number representation in computers. So let us start with unsigned numbers. From the name itself is clear that these systems are used to represent the numbers when there is no sign like positive or negative. So let us look at some practical examples where if you are dealing with the age of a person or the population, weight, etc. Normally we are not dealing with sign. We need only the absolute value or the magnitude is important. So in such cases, we can use this type of numbers, which is called the unsigned numbers. So the advantage of these type of numbers is that the entire bits can be used to represent the data. And normally these type of unsigned numbers starting with 0, then it is going to the higher number like 1, 2, 3 and so on, depending upon the data size or the data bits. So now let us consider a 3-bit number and we'll try to find all the possibilities of these numbers or all the options of these particular numbers. I mean a 3-bit number. In order to get it, the easiest way is that you can start with the lower bit or the LSB, which is 0, 1, 0, 1, 0, 1, 0, 1, then 0, 0, double 1, double 0, double 1, then 4 zeros and 4 ones. If you write this sequence, then we'll get the entire possibilities of the 3-bit number. So 0, 0, 0, if you convert into corresponding decimal, we'll get 0. This is equal to 1. This is equal to 2. This is 3. This is 4. This is 5. This is 6. And this is 7. So we found all the possibilities that we have. Starting number is binary number is 0, 0, 0, which is equivalent to 0, and the largest number or the highest number is 1, 1, 1, that is equivalent to 7. So we have the complete range of 0, 0 to 7. So if you look at the total numbers, we'll have 8 numbers are available. 8 numbers, or you can say that there are 8 states are there, binary states are there, starting from 0 until 7. We found that for a 3-bit number, the range of numbers from 0 until 7. Now let us consider a 4-bit number, and we are going to follow the same procedure, starting 0, 1, again 0, 1, 0, 1 and so on, 0, 1, 0, 1, 0, 1, 0, 1. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7 and 8. So totally we need 8. How we are getting 8, I will tell you exactly. Now next is going to be 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0 and 1, 1. The third column is supposed to start with 4 zeros and 4 ones, 4 zeros and 4 ones. And the fourth column is supposed to have 8 zeros and 8 ones. If you write the 4-bit number in this particular sequence, we will find all the possibilities. This 0, 0, 0 is equivalent to decimal 0. This is equal to decimal 1. This is 2. This is 3. This is 4. This is 5. Here is 6. Here is 7. Here is 8. Here is 9. Here is 10. Here is 11. 12. 13, 14, and finally we have 15. So what you can find that when number of bits is 4, we found that there are totally 16 states are there, or 16 combinations are there, starting from 0 until 15. So if you combine the two examples that we have seen before, when n was 3, we found there were 8 states and the numbers are starting from 0 to 7, whereas when n was 4, there were 16 states and the starting number is 0 until 15. So from these two examples we can develop a general rule. That rule says, like, for an n-bit unsigned number, the range of the numbers that can be represented using the equation 2 to the power n minus 1. So the starting number always 0 and the maximum number is represented by 2 power n minus 1. Let us try to solve one question. This question is to find the range of 8-bit unsigned number. So in this case, n is equal to 8. As you know that the unsigned numbers are normally starting from 0 to, the rule says 2 power n minus 1, and since n is equal to 8, so we will get 2 power 8 minus 1. So 2 power 8 is 256 minus 1. So you find the answer, maximum number that can be represented is 0 to 255. The minimum number is 0 and the maximum number is 255. Now let us look at the signed numbers. The signed numbers are used to represent numbers with sign. So let us look at some of the examples, practical examples. Let's say the relative temperature. So relative temperature means the temperature with respect to a reference. So normally we refer the room temperatures like positive temperature, negative temperature, with reference to the atmospheric temperature. So it can be positive temperature or negative temperature. The pressure can be positive or negative pressure. And also if you look at the AC signals, such as voltage signal, current signals, current waveforms. And similarly, in the case of biomedical signals such as ECG signal, EMG and other similar signals, where you find that there are positive and negative part of the signal, or positive and negative transitions. So in such cases, it is required that the numbers has to be represented using the positive and negative signs. So let us look at a signed number. In the case of signed number, out of the n number of bits available, 1 bit is used to represent the sign. So 1 bit is reserved, and normally the MSB, the most significant bit, is used to represent the sign, and remaining n minus 1 bits are used to represent the data. So the MSB, which is the most significant bit, or the leftmost bit, will be reserved for sign, to represent the sign, whereas the rest of the bits, or the rest of the digits, like n minus 1 bits, are the digits that is used to represent the corresponding data. Now if the sign bit is 0, then the number is a positive number, and if the sign bit appears 1, then the corresponding number, it is a negative number. It is also very important to note that when the sign bit is 0, already we said that number is positive, and the remaining 1 bit is, as we said, one of the bit is reserved for the sign, and the remaining n minus 1 bits indicate the value of that particular number. And if the number is 0, if the sign bit is 0, the number is positive, and normally the remaining number is represented in true binary format. So which means that you can directly transfer this number into decimal, by using the normal conventions of transferring a number from binary to decimal. In other words, if the number is a negative number or the sign bit is 1, then the numbers are the corresponding number which is not in true form. This form is normally we call as the 2's complement form. So which means that to convert a negative number from a binary to decimal, it needs some extra steps which is called the 2's complement transformations. This I am going to discuss you very soon. Now let us consider an example, a 3-bit number, a signed 3-bit number, and in this case, assume that the number is 0, 0, 0. The first 0, which is the MSB bit, is used to represent the sign. Since it is 0, the number is a positive number, and the remaining 2 bits, which is 0, 0, represents the data. Therefore 0, 0 is nothing but 0. So this number, binary number 0, 0, 0, signed binary number 0, 0, 0, is equivalent to positive 0 in decimal. Similarly, if you look at another example like 0, 1, 1. So this 0 indicate it is a positive number, and 1, 1 is binary. If you convert into decimal, as we know the basic rule, 1, 2, 4, 8 and so on. So if you want to convert 1, 2, so we are supposed to add these two numbers, so we will get 3. So this is equivalent to plus 3 in decimal format. So in this case, the conversion is very easy. If the sign bit is 0, so it is a direct transformation from binary number to decimal number. Now consider another example, 1, 0, 1. So if you want to transfer this particular number from binary, which is a signed binary, into corresponding decimal, as we said before, we look at the MSB. Since MSB is 1, this number is a negative number, and the remaining 0, 1 indicate the data. As we have already said, the 0, 1 not in binary form. It is in a format that is we call as 2's complement form. So in order to transfer this number from binary to corresponding decimal, so we are supposed to follow the procedure called 2's complement transformations. To find the 2's complement transformation, and it is worth to mention that these 2's complement numbers are used to represent only negative numbers. So in order to transfer a number from a negative number to corresponding decimal number, we have to look at the search for the first one. From the right side, you have to scan for the first one. So you copy all the numbers including the first one. So in this example, our first digit itself is 1. So just mark like this. Then you copy 1 exactly the same. Then after that, the remaining numbers you have to flip it. So flip means the 0 becomes 1 and 1 becomes 0. So in this example, we are supposed to have a number which is 0, 1, 1. And if you transfer this number 0, 1, 1 into corresponding decimal, we will get 3. And this number indicate, the first MSB indicate that it is a negative number. Therefore, 1, 0, 1 binary, signed binary is equivalent to minus 3 in decimal. So now let us look at one example here. Suppose we have a number which is a signed binary number 11100. So the first task is to check what is the MSB. What is MSB? So in this example, we found that MSB is 1, which means this number is a negative number and the data is represented in a format we call as the 2's complement format. So if you want to transfer this number into corresponding decimal, so we should follow the following steps as we have mentioned before. From the right side or from the LSB, you scan until you find the first one. So in this example, we can find that this is the first one. So you have to copy the entire bits, including the first one, 100, exactly the same way. Then after that, you start flipping it. So 1 becomes 0, another 1 becomes 0. So this indicates that this is equivalent to 1, 2, 4, 8 and so on. So if you look at this number is equivalent to 4, and from this the MSB, I mean the most significant bit, we found that this is equivalent to -4. So I would say 1, 1, 1, 0, 0 is equivalent to -4 in decimal. Now the range of numbers that can be represented using the signed binary is obtained by the relation or the rule. In the case of signed numbers, 0 is considered as positive, 1, 2, 3 and so on, and the maximum positive number is obtained by the equation 2 power n minus 1 minus 1. The meaning of this n minus 1 indicates that out of the n bit, 1 bit is reserved for the sign. So you will have n minus 1 digits to represent the data. Similarly, if you look at the negative part, the negative side, your number, the minimum number is -2 to the power n minus 1. Now, suppose we have a 3-bit signed number, and here you can see the sequence, all the sequence of the 8 states starting from 0, 0, 0 until 1, 1, 1. And already we said that it's a signed number, so it's having positive part as well as the negative part. So if you look at the first 4 numbers, the MSB bits are 0, which means that these numbers are all positive. Whereas if you look at the lower 4 numbers, the MSB is 1, which means the number is negative. And these numbers, since it is positive, they are in true form. So it's a matter of just transforming them into corresponding decimal. So this is equal to +0, this is equal to +1, this is equal to +2, and this is equal to +3. But if you look at this number, which is 100, since MSB is 1, it is a negative number, and all the negative numbers, they are in 2's complement form. So in this example, what we are supposed to do, we have to transfer this is into 2's complement form. So 100 is we have to transfer into corresponding decimal equivalent. So we have to scan for first one starting from the LSB. So you just skip this one, you skip this one, and this is the first one. So you copy entire one. We don't have any other bits afterwards. So you have to copy the entire bit. So we'll get a number which is nothing but 100. So this 100 is nothing but 4. Therefore, this number 100 is corresponding to what we call -4. Similarly, if you look at 101, this is a negative number and it's a signed negative number. Then we have to find out the corresponding 2's complement number. So we have to copy the first one, then you flip remaining numbers. So you have 1 and 0. This indicates that it is equal to 3 because 1 plus 2 is 3. So the corresponding number is supposed to get here is -3. Then the next number is what? 110. So we have 110, again it is a negative number, not in true binary form, it is in 2's complement form. So you have to scan for the first one, this is the first one, you copy the entire number until that, including the first one, then after that you flip it. So when you flip it, 1 becomes 0. So this number is corresponding to 2. So since it is a negative number, we will get minus 2 here. Then the last number is 111. Again 111. This number indicates that it is a negative number and the number is in 2's complement form. So you have to scan for the first one. The first one is here, which is right here. You copy the first one, then you flip it. So this will give you corresponding number is 1. So you'll get here, this is equal to minus 1. So now if you look at the sequence, if you just arrange it in the order, you'll find that the positive numbers are 0, 1, 2 and 3. The negative numbers are minus 1, minus 2, minus 3 and minus 4. So if you go back to the same rule that we have studied before, in the middle we have 0 and this side we have 2 power n minus 1 minus 1, and this side, negative side, we have minus 2 to the power n minus 1. So if you same rule if you apply, in this case we have n is equal to 3 bit. So n is equal to 3 bit. So in the middle we have 0, which is already we said it is positive 0. 0 is normally represented by positive. 2 power n is 3. So 3 minus 1 is going to make 2. 2 minus 1. And this side you have minus 2 to the power n minus 1, which is 3 minus 1, which is equal to 2. So if you transfer this, we'll get minus 4 and minus 4, and this will be 0 plus 0, and this is 4. 4 minus 1 is going to get 3. So we have the same rule here, So this is 0, so we have the middle 0, and the upper number, the positive number is plus 3. We have plus 3, and the lower number, which is minus 3. So this is how you transfer a positive numbers, signed numbers and negative number into corresponding decimal. So I'll repeat the same point. In the case of a positive number, the MSB has to be 0, and the remaining number you can transfer directly into the decimal number by using the standard rule, transferring from binary to decimal rule. But in the case if the number is negative, that means MSB bit is 1, which means that the whole number is represented in the 2's complement form. Therefore, you're supposed to transfer the binary number from to the corresponding decimal number using the 2's complement transformations. And for the 2's complement transformation, we said we have to scan for the first one from the LSB, and you have to copy the all numbers until or including the first one. Then after that, you have to flip the numbers, because 0 become 1 and 1 become 0. Let us try to solve one question here. Suppose the given bits is 4-bit number. It is a signed bit, and we have to find out what is the range of the numbers. What are the range of the numbers that can be represented using 4-bit? Okay, so as we know the basic rule, 0 in the middle. This side we have 2 power n minus 1 minus 1, and this side we have minus 2 power n minus 1. Since n is equal to 4, then the above equation becomes minus 2 to the power 4 minus 1, which is 3, plus 0, 2 power 4 minus 1, which is 3, minus 1. So you will have plus 7 this side, plus 0 here in the middle, and you have minus 8. So you can have the range of numbers like this, which is positive 7 and minus 8. Now let us repeat the same question when n is equal to 8. So if it is n is equal to 8, then as we said, 0 in the middle, 2 power n is 8, so n minus 1 is going to be 7 minus 1. This is going to be the positive number, and this side we have 2 power 7 minus. So this is going to be 0. We'll have 2 power 7, which is 128 minus 7 is going to be plus 127, and this side we have minus 128. You can also try the same method to find the range of numbers. For example, n is equal to 10, n is equal to 12, and so on. So to conclude this particular lecture, today we have seen different numbers, I mean the signed and unsigned numbers, and how they are represented in digital computers. And we concluded that in the case of unsigned numbers, there is no importance for the sign. So the entire bits that is used, or the entire digit is used to represent the data, while in the case of signed numbers, one bit, the most significant bit or the most significant digit, that is used to represent the sign. So if it is a positive, I mean if it is a 0, if that bit is MSB, or the most significant digit or bit is 0, it represents a positive number, and the remaining bits or the remaining the part which indicate the number in true binary form. So you can follow the regular method for transferring a binary number into decimal number. But if it is the MSB is 1, which means that the number is negative and the entire number is in 2's complement format. So in order to find the corresponding decimal equivalent, we should follow 2's complement method. And in the case of 2's complement method, what we are supposed to do is to start from the LSB, look for first one. So you copy the entire bit sequence, the same pattern, including the first one. Then after that, flipping the remaining bits, means 0 become 1 and 1 becomes 0. And the rule also very important, that for a unsigned number, the range is given by, for an n bit unsigned number, the range is given by 2 power n minus 1. There is no positive, no negative, and the starting number always 0. This is for unsigned number. And for signed number, the rule say that because we have positive part and negative part, and 0 always considered in the positive side, and this side will be, I mean the maximum positive number is obtained by the equation 2 power n minus 1 minus 1. This indicates that one bit out of the n bits is reserved for sign, and the negative part is indicated by minus 2 to the power n minus 1. This rule is something very important. So remember, 0 in the middle, the positive number is obtained by, the maximum positive number is obtained by 2 power n minus 1 minus 1, whereas the negative number is obtained by minus 2 to the power n minus 1. This particular rule is very important, and this concept we are going to apply in different type of the data types in C programming. Okay, thank you for watching this video. We'll see again the next lecture.